So, no, we got this. We got this. I enjoy graphing. All right, number 23. 23. We got y is equal to tangent of 1/2 theta. If there's something you have to remember, all the trigonometric functions have a period of 2 pi with the exception of tangent and cotangent. Tangent and cotangent have a period of pi. Now, we are going to compress across the x-axis by a factor of 1/2. Compressing by a factor of 1/2 is the same thing as multiplying by 2. So our new period is actually 2 pi. Okay, this is going to be weird. The reason why this is going to be weird is like, we're only going to get like half a period. Watch, I'll show you. So like, I recommend like drawing this a little bit extended more than a period because it doesn't line up perfectly. You'll get like half a graph and half a graph. I'll show you in just a minute. So, you know, I'm going to put 2 pi, which is a period. And I'm going to put another 4 pi here. I go out 2 pi. All right. And to be honest, I only really need to cut this in half once. So this is pi. And this is 3 pi. Okay. That's good enough. All right. So tangent. Okay. Tangent theta in general. Tangent theta is y over x. If that makes sense. I'm going to plug in points, kind of like what we normally do, because I want to get my asymptotes, and I need to figure out what my asymptotes are. All right, so when I look at 0, specifically, when I look at 0 on the unit circle, I know this point is 1, 0. This point is 1, 0. When I plug it in here, I'll get 1/2 times 0. 1/2 times 0 is 0. Tangent of 0 is the same thing as y over x. Y is 0. X is 1. So therefore, it's 0. Tangent of 0, 0. Now let's plug pi in there. That's equivalent to saying tangent of pi over 2. Pi over 2 is right here. This is 0, 1. We have a huge problem here because tangent is y over x. But now our x value is 0. So at tangent, we'd be dividing by 0. So we have to have a vertical asymptote there. Okay. 2 pi. At 2 pi, let's plug it in. 1/2 of 2 pi is pi. At pi, we have the point -1, 0. My x is -1, my y is 0. That's going to be 0. Now, my normal period here, this period was 2 pi. If I were to draw this, the way I would draw it is I would follow asymptotes. So let's take this region right here. From 0 to pi, we're in the first quadrant. Let me state that again. Since this, whatever's in this region, is going to be cut in half, because it's 1/2 that value, we're going to be in the first quadrant. since these theta values go from 0 to pi, and we're finding tangent of 1/2 of theta, well, all those values are going to be cut in half, and we're going to be in the first quadrant. Tangent is positive in the first quadrant. So we know we pass through this point. We know we pass through that point. It's going to look something like this. But if you notice, like, the other side's not drawn. All right, we have a vertical asymptote between pi and 2 pi. Between pi and 2 pi. So think of 1/2 of these values. 1/2 of pi is pi over 2. 1/2 of 2 pi is pi. So that's in between pi over 2 and pi. That value is negative. And I'm going to look like this. Oops, it's a terrible graph. Like that. And if you notice, technically, that's one period because it's going to start repeating here. But it just looks ugly. It's like, it doesn't look nice. So I'm going to continue this like one more thing over. All right, so now I go to 3 pi. I plug 3 pi into here. So I get 3 pi over 2. Tangent of 3 pi over 2. Let's take a look. 3 pi over 2 is down here. This is negative, negative. This is 0, negative 1. My x value is 0. So I don't have a value there. So there it is. And my tangent graph will look like a piece of bacon standing up. And there we go. Again, I just extended it a little bit so I can get like a good looking period. If I wanted to, I could go the other direction. I could do this as negative pi. When I plug negative pi into there, I'll get 1/2 of pi, or pi over 2. Pi over 2 is actually negative pi over 2 is down here. It's definitely going to be 0 in the denominator. So we're going to get another vertical asymptote. And we get our shape that looks like that. Again, this is where like the values on the x-axis matter. On the y-axis, it doesn't matter. It doesn't matter. All right, next problem. Yikes, that took a long time. 7 minutes. Great. 24. Y is equal to 3 secant theta. Draw this. Okay, so secant is 1 over cosine of theta. I guess I can put a 3 out there. This is 3 times 1 over x. 1 over x. Remember, x is cosine theta on the unit circle. All right. This does have a period of 2 pi. All right, here's pi. Here's pi over 2. Here's 3 pi over 2. Perfect. All right, here's, I guess here's 3. Oh, yeah. I guess 3 and negative 3 is fine. All right, put our asymptotes in. On the unit circle, where are the x values 0? The x values are 0 at pi over 2. I don't know why I'm hesitating. At 3 pi over 2. And so on. All right, again, this is only going to be like a portion of the graph. If you want like a full period, I don't know what I'm trying to say, you might want to put a negative pi over 2 in there. Okay, at 0. So we're at 0. I'm going to plug it into here. Cosine of 0 is 1. 3 times 1 is just 3. Here we go. Here it is. Here it is. Notice that the numerator is 1. The numerator is never going to be 0. We're never going to get roots. We follow asymptotes, so therefore we're going to have a graph that looks like this. Let's go to pi. At pi, so if I take cosine of pi is -1. 3 times -1 is -3. You have something that looks like this. Let's do 2 pi. At 2 pi, cosine of 2 pi is 1. 3 times 1 is 3. You'll have something like this. See, you have to go kind of outside. Like you'll look at it, the period. See, if you go from -pi/2 to 3/2, the period is 2 pi. But if you just draw from 0 to 2 pi, it looks a little weird. I just got a phone call. I don't know where I was at, but I guess that's why I like to include a little bit further out, just so I can kind of get the whole picture. But if you wanted to, technically, if you're just I'm just going to do 0 to 2 pi, this would be correct. If you notice, it starts repeating like this ends it, right? And then it starts repeating right here. So, no big deal. It's no big deal. It looks cool. It looks cool. Wow, this is going to be a long homework. 25. So there's 25. We get y is equal to 2 cotangent theta. It's very hard to show the vertical stretch on these graphs. It's very, very difficult. I don't see you being tested on the vertical stretch. I see it being tested on the vertical stretch for sine and cosine, but not for cotangent and secant and tangent and all these other ones. All the other ones. It's just hard to see. Anyways, I'm going to continue here. So here's my cotangent graph. I know the period is pi, so I'm going to drop a pi in there. And I really just need another point, pi/2. And I can graph this. The cotangent actually lines up nicely. So it's actually shifted pi/2, so everything kind of fits perfectly. Cotangent, so I'll say 2 times, is equivalent to cosine over sine, so x over y on the unit circle. So just looking at the unit circle quickly, 1, 0, 0, 1, -1, 0, and 0, -1. I don't know why I wrote that. I want to find all the asymptotes. So we're going to get an asymptote where y is equal to 0. Where is y equal to 0? Y is equal to 0 at 0. And pi. See, it fits. Cotangent fits perfect. Cosecant fits perfect. Tangent and secant, they just look weird. You have to draw the period a little bit longer. All right, so how do I do this? Well, I know we're going to have this root here. When I plug cotangent of pi/2, cotangent of pi/2, I'm up here. I get 0 over 1. 0 over 1 is 0, so I get a root right there. And that's my only root. And then I just go in the first quadrant. So between 0 and pi/2, that's the first quadrant. That's right here. And then I go what is cotangent? Is that going to be a positive value or a negative value? Well, since the x and y's are both positive and we're taking the ratio of those, the result's going to be positive. So it's going to look like between pi/2 and pi. I guess in theory this could bounce up, but it doesn't because we know what cotangent looks like now. It looks like a standing piece of bacon or something. I don't know, or a slide. I don't know. Between pi/2 and pi, this is now the second quadrant. Cotangent is actually negative in that quadrant. So we're and there's our graph. And there's our one period. If you want a second period, you go out to 2 pi, and this would be 3 pi/2. And then you just make the same arguments. These are your asymptotes, and then this is a second cycle of the graph. But you'll just need one. No big deal. All right, on to 26. Oh my God. I got this. No, I got this. Y equals cosecant of 1/2 theta. Okay, I know this is going to be weird. So cosecant has a period of 2 pi. So we have 2 pi. We have this 1/2. How's that going to affect it? Well, we're going to compress by 1/2. And so we get a period of 4 pi. All right, so I'm going to draw this in here. Hopefully this one makes sense, I hope. You know what might be even easier is if you actually draw the corresponding trig function. So I'm gonna draw the sine of 1/2 theta, and I think it's gonna be easier. It's gonna like you don't have to refer to the unit circle anymore. Watch, I'll show you. So sine, let's see, sine of, if I plug 0 in there, 1/2 times 0 is 0. If I plug pi in there, I get sine of pi over 2. Sine of pi over 2 is 1. 1. And then I plug 2 pi in there. 1/2 of 2 pi is pi. So like, plug 3 pi over there. We get 3 pi over 2. Sine of 3 pi over 2 is -1. Yeah. And then I plug 4 pi over there. That's get sines of 2 pi, which is 0. And then cosecant is really 1 over y, right? So wherever y is 0, or if you want wherever sine is 0, you're going to get a vertical asymptote. So like you'll get a vertical asymptote here, and a vertical asymptote here, and a vertical asymptote here. You know, I'm gonna like, I guess I don't need this. Okay, so that's my corresponding sine function. Yeah, I think this is easier. And then my cosecant graph, well, I know this point exists on my cosecant graph. Cosecant of pi over 2, cosecant of pi over 2 is 1. Okay, so I know I don't have any other roots, and I follow asymptotes, so I go up like this. Yeah, I think it's easier that way. Maybe? Don't know. Maybe. I don't know. I think so. All right, 27. It was like, I don't know. It organizes it better, I think. I'm going to do the next one, though. All right, so 27. Oh, by the way, that cotangent that's multiple of 2, I mean, in theory, it would stretch it more like this. Like stretch it more, but like it's really hard to see. All right, 27. Y is equal to 2 tangent theta. Again, this like vertical stretch is very difficult to see. Remember, tangent theta is going to be sine over cosine, or if I want y over x. I don't know about like graphing a sine or a cosine function because it uses both of them. I don't know if that's going to help you. Maybe it'll help you. I don't know. Or just the unit circle, I guess. I don't know.
Let's go to something.
Oh, shoots.
What's the scientific calculator?
All right, sorry about that. I missed a portion of my daughter's soccer game, but I'm good. They won. It actually wasn't like fair. They, I think it was like 8-0. It's like the middle school teams, but like our middle school team has like all club players, and the other middle school had like no club players, so it wasn't even fun. I don't know how they would fix that, but anyways, I'm moving on. All right, so 27, y is equal to 2 tangent theta. Remember, tangent on the unit circle is y over x, or sine theta over cosine theta. You know, you have this also definition. Hopefully your teacher talked about that. Oops, cosine. It's awkward. Sine theta over cosine theta. Those are all the same thing. So whatever you need to use to kind of come up with this graph. Anyways, let's look at the graph. This has a vertical stretch on it. Again, it's like really hard to show. Tangent has a period of pi, so I'm going to drop pi in here. And then this is pi over 2. And this is 0. And I forgot that whole negative pi over 2 thing. I don't know. Like, I'm just going to continue here. What do I do next? Well, I know my period is pi. I'm just going to start plugging numbers in. And hopefully this whole thing works out. So at 0, I guess I have to show the unit circle. At 0, we have the point 1 comma 0. Our x is 1 and our y is 0. So 0 over 1 is just 0. We have a point there. At pi over 2, we're up here on the unit circle. This is 0 comma 1. Now we're dividing by 0, so we're going to get a vertical asymptote there. And at pi, it's going to be 0 again. And this is our tangent function, so it's going to look like this, and it's going to look like this. In theory, I mean, that is one period. Again, I think I've mentioned this, but it really does look weird. I'd almost go a little bit more out, just so you can actually get like a legit period. This is 3 pi over 2. At 3 pi over 2, you'll divide by 0 again. So you'll get a vertical asymptote. And so your tangent looks like this. I feel like this is like the graph of tangent theta. So tangent 2 theta, it would just be like stretched. But again, I don't see you guys being tested on this. It looks, something faster like this. It's terrible. Anyways. On to the very last problem. This homework was rough, and we still have a couple more days of graphing. I went through this as a student, obviously, and I'm going through it again, but it is what it is. They're not crazy hard. On this one, okay, so the period of secant is 2 pi. So we're compressing by 1/3. So we have 2 pi over 1/3. So our period is 6 pi, if that makes sense. I draw my graph here. 6 pi. I'm going to split that in half. That's 3 pi. Let's make sure it's 1/3. Yep, perfect. 3 pi. Split that in half. That's 3 pi over 2. I refuse to use decimals. Now I have to split this in half. Maybe 9 pi over 2. I think that sounds right. You're basically counting by 3 pi over 2. So this region here is 3 pi over 2. Add another 3 pi over 2, that gives you 6 pi over 2. Add another 3 pi over 2, that gives you 9 pi over 2. Add another 3 pi over 2, that gives you 12 pi over 2, which is just 6. Anyway, so let's plug in some points. I think I'm going to do that. Let's graph its reciprocal function, I guess, and do cosine of 1/3 theta, just because I think we're more familiar with this, and we don't have to use the unit circle. I don't know. I don't know if I like it or not, but let's give it a try. So at cosine theta, when I first start at 0, 1/3 of 0 is 0. Cosine of 0 is 1. So we start up here. And then when we go to 3 pi over 2, we go to this value here. We plug this in. So we get cosine of 1/3 times 3 pi over 2. The 3's cancel out. You get cosine of pi over 2. Excuse me very much. Cosine of pi over 2 is 0. When you plug 3 pi over there, you get 1/3 of 3 pi, which is just this pi. Cosine of pi is -1. Something like this. I'm going to dash this. Dash. To be honest, I don't even know if I need that graph. I feel like if I just had the points, I can graph it. And the reason why we're graphing this guy, and this guy is really 1 over cosine of 1/3 theta. So wherever cosine is 0, we know we're going to get a vertical asymptote. So like here, and here. Sure, I'm just going to leave it like this. I don't mind. So we're going to get a graph. Here's our final graph. I'm going to do a different color. Our final graph is going to look like, and then starting from this point here, I follow asymptotes. By the way I got this point, obviously I plugged 0 in there. Cosine of 0 is 1. 1 over 1 is 1. That's how I got that point. Same thing here. Same thing here. But now we look like that. And I'll say that's a period of the secant graph. It's not bad. It's not bad. I would take this answer. I would take this answer. Thank you.